All right, guys, so we're going to talk about applications of the definite integral. So let's start with something important. So if I give you an integral, any old integral, from A to B of f of x dx, here's what we know. We know that this thing makes a shape, and it's bounded on the left and the right. So let's draw some function, right? And here's x, and here's y. That's y. Let's fix that. Okay. Stop trying to help me, computer. All right. So there's x, there's y. And here's what we know. A, B, right? A and B. And this thing is going to be bounded on the left and the right by A and B. And on the top by the function f of x. And on the bottom by the x-axis, right? So that, and you're going to get some area. So here's the function f of x, and that bounds it on the top. Y equals 0. Let me highlight that for you. Y equals 0 is the x-axis, right? So this is the line y equals 0, right? And so it's bound top and bottom, left and right. We get a shape. This shape may be a rectangle or a triangle, or it may be some shape that's not defined by simple lines, right? Because f of x is a curve. But this integration equals this area right here, highlighted in green. Okay? Now, the other option we have is we could have, right, here's y, and here's x, and we have some function that does something like that, right? So here's f of x, and here's a, and here's b, right? And we go down, and we go down, and this time the function is the bottom of the boundary, right? The function's the bottom of the boundary, and a and b are the left and the right, and y equals 0. Here's y equals 0 again, right? Here's y equals 0 again, is the top. But either way, y equals 0 is the bottom or the top. The function is the bottom or the top. A and b are the left and the right. Now, one other thing for you to remember. This guy here has a negative area. Right? Negative because it's below the x-axis. Negative because it's below the x-axis, right? Now, this guy here has a positive area. Because it's above the x-axis. So far so good. This is what we need to keep in mind. Now, let's move this thing and try some more stuff here, okay? So we've got this going, okay? So now, negative area, positive area. So far so good. Now, I'm going to give you a what if scenario, okay? What if we have a function, draw it in red, we have a function that does something like this. And we have A and B. Okay, what if? So now what happens? Well, this part here is negative, right? And this part here is positive, right? So some negative, some positive. Okay? What can we do? Well, it's pretty simple actually. We can go in here and find this point. There's a magic point. Okay? C. And C is where f of x equals 0. Okay? Now, follow along here. The integral from a to b of f of x dx, and f of x is our original function here, right? This red line is equal to the integral from a to c f of x dx plus the integral from c to b f of x dx. Now what we've done is we've literally broken this down into the negative part and the positive part. Okay, the negative part and the positive part. Okay, negative part and the positive part. So what we're saying here is if you have an integral, a definite integral, okay, so here's a definite integral, I can take that definite integral, integral 8 from a to b of f of x dx, and I can break it into two separate integrals and add them. Now, if I put the negative part in the back, if I put it all the way to the right of this equation, it would actually be this f of x dx from c to b minus the negative part. Okay, so keep that in mind. We can do that. So what does that set us up for? Well, it sets us up for a situation like so. So let's scroll that up out of the way. Okay, it sets us up for this situation here. Another what if. What if we don't want an area bounded by the x-axis? And let me give you the example. We draw an xy plane, and we're going to use two colors here, red and blue. So we have a parabola f of x, and we have, well heck, let's just say a linear function, g of x, right? And he'll keep going to the left. And I'm interested in finding the area between f of x and g of x, highlighted here in green. I want to know the area between f of x and g of x. How would I do that? Well, I can break this down into two smaller pictures. Okay, so I'm going to break this down into two smaller pictures. So the first, I'm going to draw f of x. Okay, so here's f. And we've got 2 points, very important points. So I'm going to highlight these on this top graph here. A and B. Okay, A and B. And we've always integrated from A to B when we think about things symbolically, right? So A and B are where f of x equals g of x. Okay, it's where f of x equals g of x. That's really, really important when we're trying to find the area between these two. So now, back to this. So here's A, and here's B. And we've got some area, right? Some area. So far, so good. Now, here's g of x, basically a straight line. Here's A, and here's B, and we've got some area. Okay, now if you look very closely at this area in red and this area in blue and compare them to the picture at the top, if I take this, I'm going to call this A1, and I'm going to call this guy here A2, okay? This area in green is equal to A1 minus A2, okay? A1 minus A2. Fair enough? Now, how do we find A1? Well, A1, I touched something I shouldn't have. A1 is the integral from A to B of g of x. And A2 is the integral from A to B of f of x. Okay? And so what we're going to do is we're actually going to rewrite this as a single integral. Okay? And this single integral will be area between two curves. Okay? So let's write that in red because it's important. Area between two curves is equal to, and I'm going to take this equation here that I'm going to circle in red and rewrite it as the integral from A to B of g of x minus f of x dx. Okay? And remember, the way we write integrals is if we have two functions subtracted from the other, they become two unique. So this is equal to this up here circled. Okay? So that's a theorem. And what that theorem tells me, if I want to find the area between two curves, I can always, let me stress that enough, always find it by finding the two integrals and subtracting them. Okay? But there is a couple of hints. And the first one I already wrote in purple, which is A and B, those limits of integration have to be where the two functions meet. Okay? The second thing to realize is this is always going to be what we term the top function. Write that in there. And this is always going to be the bottom function. Okay? Top function, bottom function. Now, what do I mean by that? Well, if you go back to my original graph, right? So my original graph, we had, here was F, and here was G. And if we look at this, G was on top and F was on bottom. Okay, so G was on top, F was on bottom. So hopefully that makes sense to you. So this is our theorem for finding the integral or the area between two curves. So let me reiterate one more time. Okay, let me reiterate one more time. Area between two curves is integral from A to B g of x minus f of x dx. And that sounds really simple, but you got a whole bunch of caveats. One, A and B are where f of x equals g of x. And two, for this formula to work, g of x must be the quote-unquote top function and f of x must, I can't stress this enough, must be the bottom function. Okay, so if those two things are true, you can find the area between two curves. So let's do a quick example. Okay, let's do a quick example. Okay, so a quick example. Let's go back to our black pen. All right, we are given y1 equals x plus 2 and y2 equals x squared. And we're asked to find the area between these two functions. Okay, so this is what we're asked to find. First thing we got to know is, what does this picture look like? Well, I know that y equals x squared is going to look like this. So that's y2. And then y1, if we mark off our y-axis here, y1 is going to look something like this. Okay, there's y1. And so we're looking for this area in between. What do we have to find? We have to find A and we have to find B. Okay, so we set them equal. X plus 2 equals x squared. Move everything to the left-hand side. So we get x squared minus x minus 2 equals 0. This will factor into x minus 2 and x plus 1. And when we solve this, we get x equals 2 and x equals negative 1. Now, since this guy, x equals negative 1 is on the left, that's my A value. And since this guy is on the right, that'll be my B value. Cool. So we found A, we found B. Now what? Well, now we need to actually integrate. Okay, so this area that we're looking to find is going to be the integral from A to B of what? G of x minus f of x dx. Okay, well, in terms of my graph, y1 was on top and y2 was on bottom. So in my scenario, y1 is going to be g and y2 is going to be f. Okay, so what's that going to look like for me? Well, it's going to be the integral from negative 1 to 2 of g of x, or y1, but y1 was x plus 2 minus f of x, which was x squared. Okay, and if we go ahead and integrate, let me move this up because we're getting near the bottom here. If we go ahead and integrate this, what do we have? Well, the integral of x will be 1/2 x squared. Integral of 2 will be plus 2x. And the integral of negative x squared will be minus 1/3 x cubed. Now what? Now we've got to enter, right? So this is going to be evaluated from negative 1 to 2. Okay, so what's that going to look like? Well, it's going to be 1/2 times 2 squared plus 2 times 2 minus 1/3 times 2 cubed, right? So our top value of integration will go out front, right? We've already done this before. Let's erase that. It didn't come out very clearly, to the third, minus our bottom value, which will be what? 1/2 -1 squared plus 2 times -1 minus 1/3 times -1 cubed. Okay, and when we do all that math, okay, we're going to come here and we're going to find this, we're going to find that, we're going to do all this fun stuff. And what we end up with, once we do all of that, is we end up with this guy here is 10/3, and this guy here is -7/6 if you do all your math, okay? And when we take 10/3 minus -7/6, we get 9/2 or 4.5, depending on who your teacher is and what they want from you. Okay, so I'm going to want that exact value, 9/2. So that is how we find the area between two curves. So let me know if you have any questions.